Okay guys, so you wanted a video on the distance between a line and a point not on the line. So here it is, okay? So whenever you're looking for the distance between a point not on a line and a line, you're going to be given a couple of scenarios. The first scenario is the one that we started out with, where you're given 2 points that a line passes through or that's on a line, but you don't have the equation of the line, okay? And then they also give you a point that's not on the line, okay? So one of the examples that we did, let me just make this a little bit bigger. One of the examples that we did, because this is best learned through example, you should have all of the steps in your notebook. A line contains points 1, -2, and 3, 2. Okay? Find the distance between the line, so these 2 points make up the line, and the point 0, 0, not on the line. Okay? So I actually used this example partway in class today. So when you want to find the distance between the line and the point not on the line, you know, you could plot those 2 points and connect them with the line. Okay, so I did that on the next page here. Let me just show you. Let me make this like this so we can see it better. So we had the points 1, -2. Sorry, I'm going to straighten that out. Okay, so I went over 1 in the x direction and down 2 in the y direction. So this is 1, -2. That's this point right here. Okay. And then the other point that the line goes through is 3, so over 3 and up 2, and I plotted this point here. So these 2 purple points here means that, you know, I can connect them with a line. So I'm connecting them with a purple line. It's called line L. Okay. The idea is that I'm trying to find the distance between this purple line and the point 0, 0, which is right here in red. Okay, so it's this perpendicular distance here between the 2 points, and in order to find the distance I need to use the distance formula, and if I'm going to use the distance formula I need 2 points to plug into the distance formula. So what you need to remember is that this point that's not on the line is if you connect this to the line, a perpendicular distance, I can extend this out as a line. So this whole line, this dotted thing here, is a perpendicular line. All right. So it's important that when we're given this information, the first thing we do, since I don't know the equation of the line, is that I have to find it. And in order to find the equation of this line right here, I'm going to take these 2 points and find the slope of the line. So that's what I did down here. First thing I did was I found the slope, right? y2 minus y1 over x2 minus x1, clean it up, reduce the fraction, and the slope of this line is 2. And then I can take this slope and either one of those 2 points and substitute it into the point slope formula. So I chose the point 3, 2, and so it's going to be y minus y naught. Well, y naught is the y coordinate of the point here, is equal to our slope times x minus x naught, which happens to be the x coordinate of the point. And then the first thing, of course, you're going to do is distribute here to get 2x minus 6, and then solve for y, get it into slope-intercept form. And this equation here that we get is the equation of the line that passes through the 2 points that are given. Okay. The problem is that, you know, going back to this picture here, I need the equation of this perpendicular line, right? So that's why I need to find the perpendicular slope. So I use the equation of this line, and I know that the slope is 2, so that I can figure out what the slope perpendicular is. And we know that the perpendicular slope is just the negative reciprocal of the slope of our line. So our line is 2, or 2 over 1 if you want to think of it that way. So the perpendicular slope, I would flip 2 over 1 to get a half and then change the sign. It was positive here and it's negative here. Okay? Once I have the negative slope, the perpendicular slope, then I'm going to use that in conjunction with the point that's not on the line so that I can find the equation of the perpendicular line. Okay, so again, you would plug that into the point slope formula, so I did that here. And this is nice and easy because the coordinates are 0, 0, so it's just y equals negative 1/2 x. So this is the equation of my perpendicular line. This line is perpendicular to this line, okay? In fact, this line right here is the pink line in my picture, okay? This is the equation of the perpendicular line, negative 1/2 x. Okay, then the step says, well, now that we have the two equations, the equation of the line and the perpendicular line, now we need to set those two equal to each other to find the x coordinate of the point at the foot of the perpendicular. What's the foot of the perpendicular again? The foot of the perpendicular is, you have this purple line here, you have this perpendicular line from the point that they give you to that line, right? There's my little 90-degree angle. So where the 90-degree angle goes, there's a point there on the line, and that's called the foot of the perpendicular. So I'm looking for the x and y coordinate of that point, because if I can find that, then I can take that point plus this point here, which is 0, 0, and plug it into the distance formula to find the distance. So we set the two equations equal to each other. I got rid of the fractions by multiplying every term, both sides, by a positive 2. So I'm going to get 2 times 2x is 4x, 2 times negative 4 is negative 8, 2 times negative 1/2 is negative 1 times x. Okay, now I can collect like terms. I added an x to both sides, so 4x plus 1x is 5x minus 8. When you add x on this side, negative x plus x gives you 0, so you have 0 on the right hand side. So now I have 5x is equal to 8, and solving I have x is equal to 8/5. At that point you have to find the y coordinate. When I want to find the y coordinate, all I'm going to do is take the x value that I found and either plug it into this equation or the other equation, whatever one is easier. Okay, so I went ahead and I substituted 8/5 into 2x minus 4 equation. 2 times 8 over 5 is 16 over 5 minus 4. And now I've got to create one number here, right? So anyway, I just did 5 times negative 4 is negative 20. That's a positive 16. The signs are different. We subtract and use the sign of the bigger number. So 20 minus 16 is 4, back over the common denominator, and the bigger number is negative, so my result is negative. Okay, so the coordinates at the foot of that perpendicular are 8/5, negative 4/5. Okay, now I can take the point at the foot of the perpendicular and the point that they gave me and plug it into the distance formula so I can find the distance between the 2 points. So x2 minus x1 squared over y2 minus y1 squared, 8/5 squared, negative 4/5 squared. If I square a negative number, it becomes positive, so I don't worry about the sign. 8 squared is 64, 5 squared is 25, so remember when you square fractions, you square the top and the bottom, the numerator and the denominator. Likewise over here, 4 squared, or negative 4 squared, is a positive 16, and 5 squared is 25. If you notice, my denominators are the same, so that means I could add or subtract the numerators. So I put it over the common denominator, which is 25. 64 and 16 is 80. And now I've got to clean that up, right? The rules of radicals say from Algebra 1 that if you have a quotient or a fraction underneath a radical, then you can rewrite it as the top in its own radical divided by the bottom in its own radical. And I know that the square root of 25 is 5, so I took that out. Now I need to clean this up. I have to find the factors of 80 such that one of them is a perfect square. Well, I know that 16 times 5 is equal to 80, and I know that the square root of 16 is 4, so I'm going to use that product. If I can write a product underneath the radical, then that means I can write those factors in their own radicals in the numerator. The square root of 16, let me move this over. Square root of 16 is 4. The square root of 5 stays under the radical because it's prime over 5. So while it was a lot of work to do this, and they are a lot of work, there's no getting around it, the distance, let me get the picture back out again. This distance here between this point 0, 0 and this point that we found at the foot of the perpendicular, which was 8/5 and what was it, negative, this is the point 8/5, negative 4/5. The distance here happens to be 4 times the square root of 5 over 5. Okay? So that's one of the examples of finding the distance between a line and a point not on a line. Now let me create one real quick here. How about, and it's more work if you have to find the equation of the line to begin with. So for example, suppose I said y is equal to 3x minus 2. I want you to find the distance BT between, okay, the line and the point P is, I don't know, 1, 3. Okay. Well, now I already have the equation of the line, so this is going to make it easier. If I know the equation of my line, and by the way, let me make a sketch before I go on. So if I sketch this line real quick, the first thing I do is plot the y-intercept, which is at negative 2. Let me get another color. It's the point 0, negative 2. So you plot the y-intercept, and then the slope of this line is 3, so write it like a fraction, 3 over 1. And from this point, you're going to go up 1, 2, 3. You're going to rise 3, right? Rise over run. You're going to go up 3, and you're going to go over 1 in the positive x direction. And now you've got 2 points that you can connect. And so this is the equation of the line y is equal to 3x minus 2. Okay? The point in question is at 1, 3. So I go over 1 and up 3, and here's my point P. Okay, so I'm looking for the perpendicular distance here. Okay, so that's tiny. I mean, that point is really close. So the thing is I'm trying to find this point on the line here at the foot of that perpendicular, x, y. Okay, well, I need the equation. Remember that this, I can extend that little line out. This line is perpendicular to the pink line, right? So we adjust this a little bit. Sorry about all that. I'm using my document camera, so I'm not used to using it to make videos. Okay, so I already know the slope of this line. Oops, it's 3, right? So if the slope of my line is 3, then that means that the slope of my perpendicular line is going to be negative 1/3. Okay. What do I need? I need the slope of the perpendicular line, and I need the point that was given. And what am I going to do with those 2 bits of information? I'm going to substitute them into the point slope formula so I can find the equation of the perpendicular line. So it'd be y minus 3 is equal to negative 1/3 times x minus 1. Y minus 3 is equal to negative 1/3 x plus 1/3. Right? And now I'm going to solve for y. I'm going to put this in slope-intercept form. So y is equal to negative 1 over 3x plus, now I know that this part most of you don't like, but I'm going to do block 23 wants a video on fractions. So I'm going to do it for 23. Block 21 told me they don't want a video on fractions. So block 21, if you decide that you want a video on fractions, let me know and I'll copy it over. I have to turn this into one fraction or one number. instead of a mixed number. How do I do that? Well, look, I know that 1/3 plus 3 over 1, I can't add those because the denominators are not the same. So what I'm going to do is I'm going to make the denominators the same by multiplying this fraction by 3 over 3, so an equivalent fraction. So that gives me 1/3 plus 3 times 3 is 9, 1 times 3 is 3. Now my denominators are the same, so that means I'm going to have a fraction with a denominator of 3 because they're the same, and now I can add or subtract the top. Well, we have a plus here, so 1 plus 9 is 10. So this number here is 10/3. So I'm going to rewrite the equation. The equation is y equals negative 1/3 x plus 10/3. This is the equation of my perpendicular line. Okay, so it has fractions and it's ugly, but we got a deal, right? Now what's the next step? Okay, I found the equation of my perpendicular line. I know that the equation of the line that was given was 3x minus 2, and you guys pretty much know that we have to set these two equations equal to each other, right? Because the job is, or the idea is that we want to solve this thing to find the x-coordinate of the point at the foot of the perpendicular. So 3x minus 2 is equal to negative 1/3 x plus 10/3. And ooh, we don't like fractions in our equations. So what are we going to multiply every term, both sides by, to get rid of the denominators? 3 in this case, right? I'm going to multiply this piece by 3, this piece by 3, this piece by 3, and this piece by 3. And when I do that, I get 3 times 3x is 9x. 3 times negative 2 is negative 6. Bring down the equal sign. 3 times negative 1/3 x is negative 1x. And 3 times 10/3 is 10. Sorry, my dog's going nuts. Hang on.